lot about the language and how you program based on the changes that came in C#, right? So Microsoft, they released this language called C#. It had a bunch of features, and then they did a lot of investment, right? They have options to put their money anywhere. They have a million different things they can do, but they choose very specific things. They spend like thousands of dollars developing C#, right? Maybe even hundreds of thousands of dollars. No, it's millions of dollars. And I think by looking at these features, when they add them, what they added, that gives us a good inclination on what Microsoft expects us to do with the language, right? So we'll get started. So this is me. I'm Ken Versaw. I'm a software engineering manager at Nelnet. I'm an ASP.NET Insider, which used to be a really cool thing, but now ASP.NET is open source, so everybody's an ASP.NET Insider. But I still get to put the title on my resume, so I'm still putting it on the slide. I started as a software developer in 2001. I'm a co-founder of Lincoln Code. I'm from Lincoln, Nebraska. Lincoln Code's a meetup. I hope you guys are attending meetups. They're very valuable, especially now in the climate we're in, to build your network. I hope you guys are doing that. If you're not, definitely start going to meetups. I'm also co-founder and organizer of Nebraska Code, which is a software engineering conference in Lincoln, a lot like this, but in Lincoln, and Great Plains Game Festival, which is kind of more my passion. That's a tabletop game festival, board games, role-playing games. I love that stuff. We had about 1,000 people last year, so it's a big deal. A lot of other people love it too. And I'm a father of 5. That's all you need to know about me. All right, so short history of C#. It was January 2002, and Microsoft needed a simple, modern, object-oriented language to compete with Java, right? Java had got released. It took the world by storm. Microsoft saw the future. They're eating our shorts. We got to do something. They came up with C#, right? And C# was very bare bones. It was classes, structs, interfaces, events, properties, delegates, operators and expressions, statements and attributes, right? Like all those things that you need to have a modern object-oriented language. If it was me, I would have been like, I'm done, right? But Microsoft, a little more ambitious. They got to work and got to version 2. Now version 2 was groundbreaking, right? Version 2 had a lot of things that Java didn't have, right? We have generics, didn't have for 8 to 10 years. Generics, partial types, anonymous methods, iterators. I'm going to go ahead and go into these a little bit. And I want you guys to see what's going on here, right? This is Visual Studio Code being controlled with a clicker. Are you impressed? This is the coolest thing you're going to see at this conference, controlling Visual Studio Code with a clicker. It's not, but it's still cool. So iterators. So I just want to take a look at iterators real quick. So the old way, in C#1, if we wanted to iterate over a collection, right? We've got a string. I've got an array of a string of names here. I had to do this kind of junk right here. For int I is equal to 0, I less than 5, I plus plus, and write it all out. Iterators give us this pattern right here, right? Where now I can just say for each string name in names, and then I can use that name as a variable within my code. So what does this do? Why is this better? Well, what this does is there's a lot. Now this is a simple example, right? But there is a lot of room for error in this, a lot of room for bugs. Iterators just eliminates a whole class of bugs. It's also more readable. You get a lot more meaning in the code that you're writing. And we're going to see a lot more of that going forward. All right, 3 years later, we get version 3. Now this is a groundbreaking version of C#. It's got one of my favorite language features, and I hope it's one of you guys too. I'm assuming most of you are using C#. It's called LINQ, right? Language Integrated Query. And LINQ is absolutely groundbreaking because it takes functional paradigms and it puts it in an object-oriented language, right? It hadn't been done before. A lot of these features we see, query expressions, lambda expressions, expression trees, those are all the basis of what makes LINQ work. And I know this was 2007. I was talking to Java developers in 2020, still didn't have a LINQ-ish thing. So it was groundbreaking, it was ahead of its time. We get partial methods, just like a ton of super cool things. So let's go ahead and and we get extension methods. I'm sure all you guys are familiar with extension methods. What I love about extension methods is I feel like extension methods are like one of those tools that that everybody at some point, like they grok it. And then like all the code they write for the next year is extension methods, right? They go through like their extension method era, like they're Taylor Swift, but it's code. And you can go back later and you're looking at your code, you're like, okay, I know when I wrote that code because I was writing everything in extension methods. But extension methods allow you to add functions to code that you might not even own. Now, my example here, I'm adding a word count into a string, right? So if we have a string, I can now call .word count, and it's as though I added a function, a method, into the library, the .NET library itself, which I didn't, right? I can just add it on here. It's very, very cool. And then we also get link itself. So in the old days, right, before version 3, let's say like we have an array of fruits here, and what we want to do is we want to go through that array of fruits, and we want to find the first fruit that starts with O and return that. This is kind of what we had to do, right? So we're using our iterator we just talked about, right? Our string fruit in my fruits, we go through each one, we check what's the first letter, is it an O? If it is an O, and then set that variable to that fruit, and then break out of this loop. Link allows us to do this crazy stuff right here, right? I can just say my fruit, which is that array of fruits, where I can put a lambda expression there, x is equal to x dot starts with O, give me the first one. Right? So all this code right here, these do the exact same thing. They're going to return the exact same thing. But this one is way more succinct, right? It's one line of code. I mean, I have it, whatever. It's one line code, and it just eliminates all the chances here that I could write bugs. But not only that, but it adds a declarative paradigm to it, right? So instead of me saying, this is what I want you to do, computer, do this, look for this, do this, now I say, this is what I want, you figure out how to do it. And that's very powerful, right? Okay, now version 4, we don't quite get that many cool features in version 4, I think because Link was so big. They were working on Link so hard that they gave us a couple things in version 4. We get dynamic, which I don't know who here has used dynamic right here, this keyword. It's kind of interesting to me, because this is kind of the first feature they added that actually gives you the opportunity to write new bugs and write more bugs. Right? Dynamic does not decrease bugs at all. It's exactly the opposite. So what dynamic does is you're kind of telling the compiler, don't do compile time safety checks. Just trust me, I know what I'm doing. So in this code right here, this code compiles, right? So I'm taking my variable, which is obviously just a string of hello, and I'm asking for the month method on that. Well, I mean, does string have a .month method? It doesn't. This will compile, and it's like, all right, YOLO, go ahead. Of course, when we run this, we're going to get an error like, I don't know what the hell you're doing. So mostly dynamic. I mean, there's very small use cases for it, usually like schemas, JSON schemas, XML schemas. When you don't necessarily know what's going to be coming in, well, you do know, but you can't really. So there are uses for it, but it's just kind of an interesting feature that was added. We also get like named arguments. So now, when you have like a list of parameters, so it used to be, as we pass values into a function, we might have like 15 different parameters that are there, and I've got to pass them in according to where they are in the parameter list. Now I can just say, that parameter of last name, make it this, that parameter of presentation, make it this, and I don't have to. It's a nightmare when you got 15 and you got to put the empty spaces in the right spots and try to line everything up. Just very, very error prone. Named arguments allows us to get away from that completely. All right, now version 5, August 2012, we get async, and async is huge. This is another huge feature, and I think this is fantastic because if you think about 2012, like this was before Docker and Kubernetes and it wasn't before the cloud, but it was before everybody was using the cloud for the most part. And they were already kind of predicting the world that we're writing software in right now, which is, I hope you guys are doing that too, like everything's async, right? I'm assuming that I've got pods and I've got 30 pods and a pod might close down and I can't assume anything about my infrastructure. So everything is async, and they predicted this way back in 2012, which was fantastic. And async is a huge topic. Like you can do 8 hours on async, so I'm just going to skip it completely. The async is a keyword. That's an important thing to know. So then we get to version 6, which is July 2015. This one is kind of, we're starting to get to the life cycle here where like a lot of the groundbreaking features have been introduced, right? So now we're kind of just nibbling away at the edges. We get a null propagator, we get string interpolation and exception filters. We got a couple cool things here. Exception filters, I don't know how many of you have used these. I've known a lot of people that didn't even realize you could do it. But now you can, instead of, you used to be able to do this kind of code before, like depending on what the exception is, we're gonna return different things, but you gotta do an if statements, right? So you have like a catch and then like this long if statement. Now we can filter our exceptions based on pretty much anything within the exception itself. We can use a when keyword to do that. Just kind of cleans it up, makes exception filtering a little cleaner. We get expression-bodied members, which is what I like to call the fat arrow. You guys call it the fat arrow, the equal sign and the greater than, which just kind of a nice syntax that you can use. But we get the null propagator, right? So what is the null propagator? That's this guy right here. So you have my presentation, it might be null. If it's not null, then grab the description. Unless the description's null, and then grab the short description. So this pretty much, we used to be able to write this code too, right? You just have like if presentation is not null, then if description is not null, then, and you have like this long, now they just create an operator here, the null propagator. Very, very cool. And lastly, string interpolation. So that's when we're using, with a string, we're using a little $sign in front of it, and then we can use variables within the string. So before, you kind of might have to do something like this, where you provide all the values at the end, and then you refer to them by their number, where they're at, and of course if you got 15, it's a mess. Now this down here, this is a lot cleaner, right? We can just use the name directly and use the presentation directly. And string interpolation, as we go further, gets cooler. It gets cooler and cooler and cooler. Uh-oh. Okay. It gets cooler. By the time we get to C#13, you can put anything in there. You can put lambda expressions in there. You can do whatever you want. Back in 6, not quite as cool, but still way better than it was. C#7, 2017, we get pattern matching and we get tuples, right? This is more functional concepts that they're pulling into the object-oriented language. And what they're doing is very cool because they're taking different functional concepts. They're not making a functional language, but they're making it so that you can use the language, the benefits of each different type of paradigm, and use them together. So the tuple, here I have an example of a tuple. So this just allows you to kind of not do a lot of boilerplate, right? So we could have made a person class with an age and a full name, and then called it here and everything. That's a lot of boilerplate code to write. So tuple is great if you've got just short, quick, dirty data object that you just need to do some operations on. Then you can just do it as a tuple. We get the out variable, which can be used for various reasons. Then we get pattern matching though, and pattern matching is awesome. All the F# people love pattern matching. So pattern matching, when we first get it in C#7, it's very limited. And we're going to see later, as we go forward, lots more pattern matching, lots more places, lots more different ways to do it. But in 7, we pretty much get 3 things, right? We get the is keyword, name is null, right? So we can check if something is null. We can do a type check, right? So we might do something, maybe it's a string or maybe it's a Boolean, right? Maybe somebody's passing false as a string, and so I need to do something if they do that, but if they pass it as a Boolean, I need to do something else. Or numeric, maybe they might pass in an integer or a double or a floating point. I know it's a number, this is gonna allow me to just check the type and then do the correct action. And lastly, you can just do a discrete value check, which is just kind of a switch statement over that. Pattern matching, very, very cool. All right, then we get to version 8. This is 2019, and I love this because you see version 5 was async, and now version 8, it's this whole this is every little thing that we did, right? So there's a lot of things in here, a lot of features, but it's not anything that's fundamentally changing the the language. I think the default interface is probably one of the, there's two things I kind of really liked in this version. Default interface. If you look at this, I don't know how many of you use default interfaces. This is kind of interesting. This is an interface, and I have code in it, right? What's going on there? Right? An interface is supposed to be a contract, but I have code. I remember when this came out, a lot of people, this was very controversial. A lot of people were like, what are you doing? That's not what interfaces are for. The reason they did this is for backward compatibility. So like I might have a library that has an interface that other libraries have implemented, right? And now if I add methods to my interface, they have to implement all those methods before they can use my library, right? So you might want to pull down the new version of the library, and now you have to change 50 different parts of your code just to implement all these interfaces. Now we can kind of put a default in there, and now it's not breaking changes every time we change the interface. And we also get the null coalescing assignment, which is this guy right here. What all this says is if the left side is null, set it equal to the right side, right? We could have done that with an if statement, but this is just kind of a cleaner way to do it. So if my presentation is null, make it a new presentation. If it's not null, leave it how it is. All right, then we get to 9. Once again, a lot of performance, interop, a lot of fit and finish features. We don't really care about any of that stuff. But we do get records. That's kind of the big feature that we get in 9, which they're interesting, right? I don't know if you guys are using records or not, but records are intended to be used for data objects. They're optimized for data objects. They're immutable by default, right? So I could have had a class that's an animal, and then had a name and a is furry, right? Had all the properties and stuff. I can write all that just in one line here and make it a record. If you want to make it, you can make it mutable. That's what we're doing here. If you can make it mutable, you just have to specify that this can be get and set, right? That's how you would make it mutable. But I would recommend if you've got data objects that are just classes, and you're in that code and you're working in that code, switch them over to records. You'll get better performance. If you're already in the code, like don't go through all your code and change all your data objects to records, unless you have AI do it or something. But if you're already there, this is just kind of a nice thing to do. In C#10, we don't get a lot that's cool. We get global using directives. That's probably the coolest thing, right? So global using directive, in the past, you might have system collections in every single file. You might have like a stack of usings in every single file at the top. Now we can put all those in one file, and whatever's global in that file can be used anywhere. That's pretty cool. You get this file scope namespace declaration. So that kind of saves you from starting your code over a tab, right? So you have like your namespace that's over a tab. Well, now we use a semicolon instead, and now we can just start on the left side. Kind of small, but it's something. They did it. And we're also starting to see with C#10, actually with C#9, is we're going to the yearly releases, right? So every November, a new version of C# comes out. Like every November, a new version of .NET comes out, new version of C# comes out also. So we're starting to see, and I think that's why we're starting to see kind of smaller little bits coming into. C#11, this came out in 2022. We have raw string literals, which are really, really cool. We're gonna look at those. Required members are okay. So raw string literal, so here's kind of the old way we would do a string literal, right? We would put it in quotes, and then we'd have to do like a slash to get, for escapes and things like that. So a raw string literal, you do 3 quotation marks to start it and 3 quotation marks to end it, and then you could put whatever you want in the middle. You can put whatever you want. If I console line this, it will be tabbed over and it will be centered, right? So it does new lines, it does tabs, everything. So this is very, very cool. So I definitely recommend looking into this. Raw string literals, you started with three quotes. All right, 2023, we get version 12. We get primary constructors. That's kind of the main thing. We can alias any type. So I can just kind of create a tuple here at the type, use it as an alias, and then I can use it within the code. Do a using, so anything I want to do in there I can do. Primary constructors allow us to create classes, sort of like records, right? We talked about earlier about how records have a really nice syntax. I just include the properties in the function declaration or in the record declaration. Well, now I can do that with classes too. So before I would have had to have these as properties. It would have been 3 or 4 more lines of code. Or if you had 15 properties and you have 15 lines of code, all that's eliminated now. I can just put them right in the constructor. We get, oh, I almost forgot about this. We get the collection expressions are pretty cool. These are, you can just kind of create collections just like this, throw it right in there. Then we get the spread operator. This is actually my favorite part of C# 12, right? Because I had done a lot of JavaScript before that, and I love the spread operator. So if you've done JavaScript, you definitely know about the spread operator. Spread operator allows us to pretty much copy one array into another. That's those 2 dots right there. So like this array right here is going to be the values that are in this array plus whatever I add on top of it, right? So it's just a very, very easy way to copy one array into another. In JavaScript, it's 3 dots. C# it's 2. Now we get to 13. This is the most current version. And this one, so there really wasn't a lot. This was a disappointing version, in my opinion. We get implicit index access, which I don't know, I've never needed to use this, but apparently some people really need it, so they added it. What this allows us to do is, if you look right here, use the caret in the array, and you're setting to the end of the array, right? So this data buffer, this right here, 8 would be assigned to the last element, 5 would be assigned to the second to the last element, 12 would be assigned to the third to the last element, 15 assigned to the seventh to the last element. There are times you need to do this, I guess, like maybe when you're doing games, I don't know. I've never really had to do it, but it's something they added and it was really hard, I guess. Params collection, you can now use params with any collection type, right? So now we can pass in spans into as collection types, right? And if you guys aren't familiar with spans are very fast, they're very efficient if you're doing read-only operations. That's another kind of thing you can do if you're in your code and you're using arrays or lists or something like that. You can make your code faster by using spans. Definitely check that out. We also have the overload resolution priority, which says essentially use this constructor. Like if you don't know which constructor to use out of these two, prefer this one. Now we have time for the future, which is C# 14. We get field-backed properties. We also get partial events and constructors, which I think are kind of interesting. So we'll go up to the top here. So we can now do like this employee right here. This is a constructor for employee, but I put a partial on it. And sort of what this is doing is this is allowing us to kind of add an interface onto a class, right? So whoever implements employee has to implement this constructor. Is kind of what it comes down to, and same with the event. So it's kind of like going the other way, right? So like default interfaces was putting code in interfaces. Now this is putting interfaces on code. It's kind of interesting. And then we also get a field code keyword here. So now you don't have to declare, so like right here I have a property, new hours. I don't have to declare like a new hours backing field. I can just use a keyword field and access that. And we get the no conditional assignment, which is really awesome. I got 30 seconds. So this just says right down here, if this property is null, set it to new value. So that's what we're getting in 14. Last one. This would normally be questions. We don't have time for questions. But 15 is about union types. If you're familiar with TypeScript and you know union, that's kind of what they're looking at for 15. This is kind of a tidbit. It's not in here because we're not to it yet. But that's what they're looking for, is that we can now have union types in C#. That's my time. I did it perfect. 25 minutes exactly. Thank you.